Well,
good morning. Yes.
morning. How are you?
I'm doing pretty well.
Great.
There's about, I don't know, 7 to 8 inches of snow on the ground here.
Wow.
And it's nice and sunny and like just above 30 right now, so it's all starting to melt already.
Oh, wow. It's great.
Nice.
So, yeah, how's everyone doing? How was their week? As I see that Jesse put the notion in the general channel, so
I started to type some things in the Notion page titled EI 23 abstract submissions. I tried to get an abstract for that embodied Neuro Phenomenology idea out. So
Okay.
Still some work to do there.
yeah. That's okay. Let's see.
Nice. Yeah, let's go over that.
Yeah.
I was gonna kind of suggest, yeah, let's kind of review those, like what's cooking in terms of submissions a little earlier in the meeting, just so people like who come in and kind of get a sense of what's going on.
Yeah.
I feel like that's an important thing to do. But as far as that's good, anything else, Amanda or Bradley, that you want to share?
Not yet. We could actually just go right into the submissions and go from there.
My general
Oh, I don't really have any other updates. I've had a busy week, so I haven't really done much since the Cognition Futures meeting.
Yeah.
My general updates, we can get into some of the specifics. Have to do with there's I think I'm going to refer to a lot of the stuff I wrote, because I put a lot into last week's like Notion document, and I didn't get to put it into this one this morning, but there are a few things from last week that I'll probably go through shortly. Right. But basically my week's been busy and mostly pretty good. There's movement on a lot of fronts. There's movement on the plot treasures front. There's movement on the NYCWiC. Registration is open for NYCWiC. That's the conference that we're talking about. I've started a very simple draft of the presentation, and I haven't fully gotten that to a place where I'm happy with showing everybody. Oh, Morgan! Wow, hello, Morgan. Been a while. Happy to hear from you. I'll go through some of the just where we're at with the presentation, and we kind of got to start nudging people to like, okay, it's time to be working on this month, because it's due in mid-April. Also, kind of reiterating, we are accepted to the Bond Sustainable AI conference with the well, I'll just start. It'll be easier to just actually show some of the stuff I'm doing. But yeah, Morgan, I don't know if you have if you want to do audio or just text updates, but please share what you want. Because I know that I've been like, oh, I want to talk to Morgan about this, so it's great to see you here.
Yeah.
I have a lot of things to kind of float by you in the future about you as a Morgan, about like some like neurofeedback stuff I've been adjacent to or maybe getting involved with in the future. So to see you. All right, so let's just jump to this. So yeah, oh, that's checking my different desktops here. As far as dynamic days goes, Bradley, I also just wanted to say, like, we're pretty much all done with this now, or when did that happen in January itself?
Yeah, it happened in January. It usually is
Okay.
like the first week, so that's done.
I might take that off the list soon.
Yeah.
So as far as NYCWiC 23 goes, I don't know if I put it in here yet. What's been cool is that she hasn't really been in the lab yet, but I have someone who is working on the contributing to part of the project, and the one doing the ethics review board. Her name's Jen, and we've kind of talked a little bit about she's going to be contributing to parts on the NIH data and sort of like how the National Institute of Health is pushing forward their new data projects to make things more accessible and open source. And she's looking at that in terms of how it may affect patient impact or accessibility, and also like it's kind of going to be a segue into some other things we want to do in the future about sort of making a project that's looking at some of the ethics boards and inclusivity efforts at like tech companies, hospitals, educational centers. So that's more of like a post NYCWiC thing, but she has a background in public health. She's a background. She's interested in like diversity, equity, inclusion, and it kind of was a natural fit. So she's only going to have like a slide or two for this. It'll kind of be like underneath part of my section about open data and open science, but we have had some movement on that. And I'm going to see if I can pull up. Yeah, this is very much not like finished, but just to kind of show that it exists. I'll just do this right now. It'll be easier. Just to kind of show this, like it does exist, and we are moving forward with it. I mostly copied things this is all from like last year's that I'm kind of just preserving and would want to take with us. But here's kind of an outline right now of what we want to do with some stuff. And there's opportunities that people are seeing this and they want to jump in on any of these things. You're welcome to do so. We basically have 20 minutes to break out into three to five flash talks, or 3 to 5 topics that are going to be a little bit interrelated, but it's kind of separate segments in our presentation. They pre-recorded sort of flash talks, basically. That's the goal. So not a lot of time, but there's a lot of opportunity to join on that. So I wanted to really highlight that this is happening, this is moving forward. We are getting there. And this is the accepted abstract, just to show that. So cool. Also, for those who were interested in volunteering at NYCWiC, we can use a little bit of support in the Slack. There won't be that much to do. It's not like a big, massive. It's not anything like most other conferences. It's a fairly smaller version of things like that. But yeah, it'll be it'll be good to have. If anybody wants to volunteer in that sense, they can. But if anybody, another thing, especially if anybody does want to go like in person, I'll have to like ping. Well, it's a little bit unwieldy to be that way. I'll have to ping Brian about it. But if people do want to go in person, registration is sort of happening now. So, and there are some. We're trying to be conservative about space because there's a lot of interest this year, which is great. And the hotel is like kind of limited. So we're kind of trying to take care of that as best we can. That's kind of the NYCWiC update. Bond Sustainable AI. I don't know if anything useful.
I have a question about the NYCWiC.
Yeah.
So the virtual component, do we know how we're going to set that up yet? I mean, do we have it worked out?
I guess the short answer is no, but I mean, the plan is people like, let's finish, let people make their flash talks and just record them. That's basically what I'm going to do.
All right. Could we join in on like Jitsi? I mean, we don't have to present that way, but like, just to be able to join in.
Oh yeah.
Okay.
I'm basically going to do what we did last time, but just try to have things be more pre-recorded. So for those who don't know what we did last time, I guess, last time we had a hybrid of like in person and over the phone and pre-recorded, and it was mostly functional. And then also like live chat in the background, but through Gisty. And basically what I would like to do, what I would love to have happen is people to present their topics and maybe refer to a blog post or their writing or their research or the things they want to do, like kind of the classic, see our work in blank, but pre-record the videos, and if possible, be present at, I forget what our time slot is, but present during that weekend, Friday to Saturday. And because I will have internet access on my computers and stuff like that. So you can virtually answer questions about, your presentation or whatever. That's still on the table. But the plan will just be to kind of intro the session, and I don't know if Bradley does the introduction to the thing, but just kind of start with, pre-recorded video 1, pre-recorded video 2, pre-recorded video 3, pre-recorded video 4. I'll speak a summary and then open to questions, and that'll be it. We'll have basically 20 minutes for video and 10 minutes for discussion. We have like a 30-minute slot overall. And I wouldn't be surprised if the videos go maybe a little bit over, so we have like 7 minutes for discussion or something like that. But that's what I envision.
Okay, that sounds good.
As far as I'm concerned, anybody who's a presenter, if you want to join the Slack, there would be like a discussion section in the NYCWiC Slack also. If you want to have a virtual text component that's not just a theme, ephemerally in the Gisty, and want like actually people around to answer some questions for folks, that would probably be pretty cool. Not mandatory, but suggested or recommended. Yeah. Anything else for this one?
Nope.
Cool. Okay. So for Bond Sustainable AI, we have accepted this. We're accepted for the sustainable auditing tool, or that concept in general. We were partially accepted for this one, which is basically the plot treasures one. But after talking with Jenny and the group and kind of seeing what they wanted us to do, we're not really ready to have a kind of in-person demo or to tailor it heavily towards like climate change right now. And they kind of suggested like, hey, we're not going to give you like a slot because we have a bunch of, I submitted 3 submissions basically. Right. And they're like, well, we're basically going to cap it at 1 per group of people. They went by like group, not just like emails or anything. And I wasn't trying to be deceptive about it, but they were basically like, we know you're a part of this group, and we only really want it. We can only take one, so we're not going to do this one, which is about sort of the kind of the methods project, but tailored towards AI. And they said, this is cool, but like maybe we'll let you do a presentation of sorts in person. But I talked to plot twisters and they're like, I don't think that's quite going to work. So this one, I don't know if this is here. This one is accepted, and there, I don't. All I really have to do so far is just confirm we want to present it. So there isn't really a. I'll put accepted ends this here, because there isn't really action to take on this right now. I don't even know some of their formatting for what we have to do, other than I know it'll be virtual. I think it'll basically be like a virtual poster presentation.
Okay.
So. But the date for this will be at the very end of at the end of May. So it's not urgent necessarily.
Great.
So but that's on standby. We're basically getting down the line here. We're still waiting for CogSci 2023. I think that might be a while more. I didn't want to put, I don't think we're gonna, I'll just put this on the list, but like, this is sort of an upcoming thing. I don't know the exact dates yet, but I know I got this email about Society for Neuroscience saying, hey, renew your membership now, because if you do, you'll get like bonus day access to hotel rates and discounts before the major one. I know it's in DC, which is kind of disappointing to me because I was just at Washington DC, and I don't know if I'm going to go to Society for Neuroscience in person, but it's a pretty big thing. I mean, I really should. I think honestly, is Society for Neuroscience and CogSci, the CogSci event itself, those are like the best psychology related stuff around, or like adjacent to it. So if I can get into that at all, I have some like institutional access to it. Oh, it's in November.
Yeah, it's a ways off. It's usually then.
Okay. For some reason, their email, I thought it was in the summertime. Oh, well, that's, yeah, okay. That may not be a immediate thing. Let's just put this here. All right. And then kind of what Amanda was talking about and Bradley. And I think we may go more deeply into these things, but these are the sort of urgent things the next 2 weeks we want to really finish up. Outside of taking a deeper dive into both of these things, I will say I found some interesting stuff for Cognition Futures. I have actually been slowly going through, I think it's more originally for the Alife one, but the critical periods.
Right.
Here, I started commenting on that a bit, and it's been good to, I feel like there are some things there that are maybe will be falling a bit under the Dev AI banner about like developmental AI and I went on this sort of adventure last night, and I don't know how to really recap it, but it was sort of, I looked at a few things, and I was looking up aspects of like embodied intelligence in the 40s, and some like different takes on them, or different takes in development. I found a really, really interesting paper that I would like to talk about perhaps Wednesday, and I'll show it briefly.
Okay.
But I found a very interesting paper about people who have done some of the work that I think we want to do in developmental AI. But I try to find how much like they're cited or whatever, and it doesn't really seem to be that popular.
Oh.
It's mostly based by somebody in I think Germany, and there's a few people. Interestingly enough, one of the authors is also from an anthropology school in San Diego, but it's genetic anthropology, which I've never really heard of before. So a lot of people at like the phenotype, genotype level, and how like that changes in like social and environmental expressions, which I think is what the I think it's like Laura L. Non or something.
Oh, okay.
So
I think I know. Yeah. I think I may know who that is actually. What
Yeah,
do you have the paper?
I'm sorry?
Do you have the paper?
Yeah, I'm trying to figure out the best window to share it on. Can I just share this? Yeah, I'll share this here. I know it's a bit unwieldy, so I apologize. But, okay. I believe this itself is the paper, a developmental framework for embodiment research, the next steps toward integrating concepts and methods. Vanessa Lux. That's Amy L. Non.
Okay, yeah.
And some other folks. Yeah. So it's pretty cool. Like they get deep. Like some of their charts are really cool. Like let's combine these different approaches. They have like agency and environment. They have this sort of break it down in this way, and kind of the fields of research. Like it feels like it's kind of like it fits with some of the methods project and how we're trying to frame and scope some of the stuff out too. This was fun. And we could go, well, quite, oh, I don't know what happened tonight.
Too many times.
Yeah. And just to kind of show this really quickly. Yeah, exactly, Amanda. Like these really broad, they have some references that are associated with these different theories. And like I like how they have like the critical positions of what they are. It's fun. And then they have this big, very, very allostatic kinds reminded me map of like this. And it's a bit adjacent to some of our efforts in like it's not quite the same as like the interoception work necessarily that we're investigating right now, the Neuro Phenomenology. But I like where they're going with this, and I just feel like, oh, like it's this particular variant on like allostatic kinds and this expression of shaping and the arrows and these there's one different cycles here. It's like it reminds me so much of Avery's work in our discussions about things, and just trying to incorporate different. So that's cool and exciting. I have looked at like
what year was this? If you go up to the top,
2020, 21.
21. Okay.
So it's fairly recent, which is nice. Like I really want to take a deep dive into. I found this basically midnight last night, so I haven't really but just the references look exciting. Like the way they frame and talk about stuff, is interesting, and I think will be quite useful to a lot of our efforts, both in the methods project, but also like to preview like the critical paper period here, getting into this stuff here. Yeah, there's some Vanessa Lukshiza here. Most of her work is in these other kind of epigenetic level stuff. But is she on this paper? No, she's on this paper. I was trying to find specific words to convey something. I don't know if it's gonna let me find what I want to find here. Anyway, suffice to say, that's a whole thing to dive into later. I found this was actually quite interesting. Does anybody know what WikiWand is? It feels like AI generated text summaries of Wikipedia. And like, this is a pretty cool page. Like, I like this page a lot. I'll put it in the chat. It explains some of the stuff pretty well. Like, and it also has these questions that are sort of like, I would really like to go through, like, some of the answers for this feel better than others, but like, I like this one, which is sort of like, how does like, embedded, enacted, extended, how do these three E's fit to embodied cognition? And it, like, I think it'd be fun to kind of go through this and like review these and kind of see, I don't know, like have our take on them. But this is a very interesting page. It's a page that kind of gets at some of the theory nicely and explains we mean this, and we precisely mean this, and some of them feel a little like off, but overall it's good. So that's like a cognition feature things to discuss. I just wanted to kind of show that. What else? I guess I'll just say we can, before we dive into embodied intelligence workshop and Alife specifically, other kind of general updates for the lab are I have to reply to Michael Paglia, the intern who wants to get summer credit. I got an email back from him. There's a few internship things on the horizon that I have to reply to a few folks about. But that's on my to-do list to see if Michael can get credit through computer science department. Yeah, and kind of adjacent to everything, but not explicitly stated. Moving forward with the Dev AI stuff and kind of putting that in the context of cognition features relative to DevoWorm, relative to representation brains and phenotypes. I know that's well, actually, I'll quickly share this too, just to kind of do it. Oh no, here we go. I don't know if it's in here or this one. Just to kind of follow up from this, I'm curious if we don't have to, but I'm curious if there's sort of any further thoughts on kind of the. I think some of the questions we have about this are just what to call education banner, and Um, have you had any more thoughts about that, Bradley? I know I'm giving you totally cold off the jump start about this, so we don't have to talk about this now. But just to kind of mention, like, in the background, some of the theory work about, well, not theory, but like, I don't know, administrative language
Yeah.
work is happening here. But I might just leave it at that for today.
Yeah, I still owe you that write up on Dev AI, but I think, like, I like education and open source, but I think, maybe it has a better name. Dev AI and representational brains and phenotypes is supposed to include a lot of the agent stuff that we're doing. So it could be like Dev AI under that. There are other things that we've done work on that are under that. So I don't want to. I think representational brains and phenotypes is sort of like maybe a high level description. Maybe Dev AI is even higher, but it maybe intersects with cognition futures. It's just kind of hard to. I mean, I'll have to draw it out.
sorting them out and like relating to each other is sort of this ongoing thing.
Yeah. A lot of times people will use like terms within the lab, and it also really depends on the artifacts. So whatever we're putting out, falls into this slot, and it may be like from any project, but I really think that, like, we have these are projects, or these are aspirations that we have, and then they're actually the artifacts that come out, and the artifacts are going to look different because people were collaborating and across themes and this business. So like you're going to have something that is basically indicative of this thing that we're calling Dev AI, not necessarily a project that we're going to stick to very tightly. So yeah,
I think that's like, I haven't yet finished the new map, but just for those who are seeing this for the first time necessarily, we kind of this is basically our map from last year roughly, and we had these big 5 research banners. We had these like bigger concepts and smaller concepts like meta brains, agent-based models, critical periods, philosophy and history, digital humanities, epistemological directories, all these things. And the purple were actual outputs. They were developmental brain vehicle project, Viva Learn, which is just part of Viva Worm. Mentoring professional development was kind of this year. Internship program kind of was also this too. Frontier map was sort of a blend between this year. We didn't, and they weren't really like set in these specific columns or anything like that. But I think part of what I mean by onboarding quest here is making a map where there's sort of a streamlined process of, oh, here's a topic, here's things we cover, here's output, here are events we've presented that work at, and here are some like external partners in that, but rearranged and reorganized a bit. And it's so tough, like going through trying to find Vanessa Lux's work, I put the paper in the chat.
Yeah.
That was what I did. But trying to find Vanessa Lux's work, like, and Amy Elnon's work. And I had a discussion with my friend last night about Judith Van and her, like, how is she framing? I feel like she's a fun example for me between her and like Josh Tenenbaum of like, how do you frame your work as a cognitive science? Just like you have to kind of present your novelty and what's cool, but also like like what's your elevator pitch for people? I feel like for cognitive science stuff, it's so important. You gotta have like your relevance elevator pitch ready to go. Otherwise, it's just such a morass of like it's such a sea of
right. It's
like
hard
so many terms and just lack of clarity. So you can say, oh, well, in this space, I want to do this, and it's so weird because in a lot of these interdisciplinary things, it feels like you're it's as if you're shortchanging yourself or almost like being duplicitous by saying, well, here's my elevator pitch. So it's really, really concise that you can understand it. And so the parts of the theory I'm differentiating that I want to focus on and where I want to push them. But like in reality, like the work is to be very holistic and push like big paradigms forward and being aware of other ones. So it's like, yeah. Anyway, in efforts of keeping things moving, Bradley, do you want to talk about the Alife and AI submissions now?
Yeah, let's do that.
Let's do that.
Yeah. So
what would you like to start with?
Why don't we start with the abstracts? We're doing, like, Amanda has an abstract that she is working on. She put some things in the.
I believe that was for EI. So let's start with Amanda. If you want to talk about that or share anything, or you want to like prep that, I can talk about other things while you get that ready. So let me know what you want to do, Amanda.
It's still in progress. I don't have much to add since we met on Wednesday, but I can say that again since not everyone was there.
I will try to. Let's see. You want me to just pull up that page and have like you can talk about it that way, or
sure. Or I typed in. So I didn't realize you had like 3 different embodied cognition, or an embodied intelligence like stubs, but the one titled AI 23 abstract submissions. I also have some notes. I tagged it in the today's meeting document.
All right. Here we go. Yeah, great, awesome. So, that's good.
So part 1, Neuro Phenomenology, is Varela's like methodological response to Chalmers's hard problem of consciousness. So the mind is irreducible to like a third personal description of the world, like scientific study, and then the third personal is irreducible to the first personal in this hard problem of consciousness. So Varela puts forth this methodological solution where he describes how you could use what he calls mutually informed constraints to create this dialogue between these 2 domains. And through that whole paper that I cited in the first sentence, he talks about like the 2 domains, like the first personal and the third personal. In the Fuchs book that we're reading, Cognition Futures, Fuchs starts by reframing this mind-body problem, this hard problem of consciousness, as not really 2 domains, but what he calls dual aspectivity. This is where he draws on like phenomenology and Merleau-Ponty. So he reframes the hard problem of consciousness and essentially dissolves it and creates a different kind of starting point. So I'm interested in how, if you start from like that starting point, what could neurophenomenology look like? So Varela frames it as this response to this like irreducibility of 2 domains. But if you dissolve that irreducibility and you reframe the problem, what could neurophenomenology look like? One case study could be like going off of, and I have to connect this to the details of Fuchs's account more, because I think that would be helpful. But one case study could be like if we accept these like deep embodiment, like the strong embodiment thesis, then maybe interoception is an interesting like first personal methodology to investigate, like your immediate like sensation of your body. So if there is this profound unity between mind and body in the way that Fuchs describes, then instead of examining the more like cognitive cases that Varela looks at, like attention and time consciousness, and he also looks at emotion. He also looks at embodiment things. It's not like Varela is, a cognitivist about this. But what if you start from this stronger thesis? So I think interoception would be interesting as a first personal method. That's what I have right now.
No, it's great. And we can like this is something we can work on and flesh out. But also, like, I think this really captures nicely, like, this is a classic, like, let's reference a broad thing and introduce this thing. It has a nice, the shape it's taking, I think, is really nice, and will be very good for the venue, but also really good to kind of crystallizing. This fits really well with, like, kind of some of the efforts for kind of closing out this sort of era of conditioned features, and like this question, this line of discussion is basically going to be a really key thing for, like, where we're at with the reading group and the methods project so far. So I think this is a really nice job of, like, bringing all it together. Anything you wanted to say, Brendan?
This is great. Yeah, I think it's just kind of, we really don't need to have any references in it, but we need to kind of, I think it's probably good. I mean, it needs a little bit more maybe editing here and there, but I think the structure looks great. I mean, this is basically, I don't know how long, again, like somewhere anywhere from 5 to 20 minutes where we need to go through it. And like with a philosophical thing like this, I think it's just makes sense to kind of walk through very quickly the argument, and then maybe at the end have some examples. So, like, we walk through the philosophy and the logical structure, and then at the end we give examples of, like, what does this look like in practice. So is this, like, we're talking about interoception or proprioception, or what is a first person view, what is a third person view of that, or whatever. And we can animate it or whatever as we need to get the point across. But I think that structure would work. Just having the setting up, the motivating the problem, putting in the terminology on, like, maybe right up front, and then going through sort of how that's related to embodied cognition, and then the examples.
Yeah, what I need to find now is, like, because Fuchs's view, like, we're used to it with this reading group. We've gone through this whole book and he's, repeated himself a million times. So I feel like I have a good understanding of it, but I need to find some like just excerpts that will help me give Fuchs's view in just a few sentences.
Right.
And make it clear how that view is like a profoundly different, like, philosophical starting point than what Varela is responding to.
Yeah.
So that's my next task.
Yeah, I mean, definitely, making, because the people there won't have a philosophical background, and the slide,
Right.
a lot of the presentations will be like, very cut and dry sort of methods, results, maybe motivating things, but the motivation is usually pretty small. This is like the motivating thing here is really robust. So it's always a challenge to get that across to people, but I think it is. I think it's worth it because, I don't think people think about this very much, and especially in like robotics or in some of the other areas in computational work. It's just like people don't think about the ideas very much, at least not in the same submissions that they do the work in. So this is definitely going to be good if we can, like, make it sort of like deliver it like as a very piecemeal IV drip for people, like more, be very sort of compartmentalized with the terms. Say this is what Fuchs's view is in, like, 2 sentences, and put a quote in the middle of the slide or at the top of the slide, just so it has, like, people can take bites out of it. And
Yeah.
Maybe a short version, like a short pitch, is explaining how we can study the mind by studying the body. So one quote I didn't include is in the Neuro Phenomenology paper. Varela says, he says, like, this is what I mean by neuro. It's not XYZ. what does he say exactly? It's meant to stand for like all the third personal ways of studying the mind. So further, neuro here refers to the entire array of scientific correlates which are relevant in cognitive science. But to speak of a neuropsychoevolutionary phenomenology would be unduly cumbersome. So if neuro refers to the entire array of scientific correlates which are relevant in cognitive science, plus the strong embodiment thesis, then something like physiology would fall under that category. I think that's, if we're zooming into interoception, that physiology aspect would be the third personal. And interoception would be the first personal.
Okay.
I don't think this is the quote you mentioned.
Yeah, that's it.
Okay, it is that. Okay, here it is. Yeah.
So yeah, I would summarize that in like a couple words. But I think this is great. This is great, and then I think that'll be a very good contribution to that area. And we'll have it. That'll be a nice artifact for us, so we can, maybe recycle it for NeuroMatch later in the year, but maybe have a different take on it. So
yeah, this feels like a good seed project for the methods project in general. This feels like a good deliverable goal.
Yeah. To comment on that specifically, I think I'm starting to see, I don't know what to call them. I just heard the MIT Quest for Intelligence rattling around in my head, where they break them out of different missions and stuff like that. I don't think it's going to be quite like that, but I'm seeing different branches. Like I'm gonna go back to this. We've covered so many things, but just whoops. I'm starting to see these sort of branches emerge. One is this 1P Neuro Phenomenology, or I'll just say phenomenology, subjective stuff. The other one I think is sort of, and kind of bridging into some of the Alife material and the critical periods, is like is sort of the developmental approach. Because I think reading that paper and going through everything else and going through, I'll put this in here. Going through this paper, like I feel like they have a really nice what they're doing, what they try to put together in this paper is really nice and robust. Like this is almost like a vision paper. Like this is very much and like I've looked at one of Vanessa Lux is the lead author. She's done some of her other work has literally been in wrote in book chapters about like we need to have more integration in like some of the like biological, psychological sciences, like a lot of pushing this stuff forward here in that way. And I feel like this paper, oops, I don't know what there's something here. This paper, like I feel like I pretty much agree with what they have. I like a lot of their framing, but also I feel like what we're doing could build off of this and add our own stuff with it. Because they have like a section of like implicit and underexplored things. They have a lot of sorry, I just got a text from my mom and I thought it was like urgent or like a bad thing, but it's not. It's just they got a whole bunch of snow. So that's feel better about that being the case. But like they're pushing the stuff forward and I feel like, okay, like let's some of the things we're looking at, they don't quite cover yet. Like I didn't see a whole lot in terms of like affectivity and like kind of like bridging from Fuchs forward. Obviously, they talk about development, but I don't think they talk about development some ways that we do. So I'm kind of starting to see a lot of the submission we're talking about with Amanda here is like really capturing very well the Varela Fuchs like turn. I think some of the things in Bradley's, I'll call it your submission now. I don't know if you want to say that, but like some of the thing in Bradley's like work here is combining like we have this we have like a pretty strong history in the lab of like developmental neurostimulation, all of our Brainberg vehicle stuff. Like we kind of have this trajectory of stuff that's been in the works here. And with like the continual embodied learning, we have these different like sort of thrusts in this direction. So I don't know if we want to jump into talking about this paper now, Bradley, or anything we want to say, anything we want to finish saying about Amanda's stuff, because that was great, I suppose.
Well, yeah, that's great. I mean, we can jump right into this though, just for the interest of time.
Yeah.
So yeah, thanks for going over this, Jesse. And the submission is due the 13th, so we still have about a week.
Yeah,
this, at least.
I've only started like putting some comments in certain places. Like I'm not finished with it by any means, but just to kind of mention, people can still see this or comment on this or interact with it. So
yeah. So this is sort of driving the critical periods idea forward. And then we're doing this thing, developmental neurosimulation. So that term is like we introduced that back in the Brainberg vehicles paper that we worked on that got published last year in Alife. And the idea is that you're building these agents that are simulating the development of the nervous system and behavior. So they're like we have these agents that are generic. This isn't like a Brainberg vehicle, it's just like a generic embodied agent. So we have, we're trying to model the critical period, but the idea of critical period is a little bit broader. It's basically you have these morphogenetic acquisitions, which are acquisitions of the body. Like if you have like a eye patch or set of eyes that develop, those things are acquired from the genome, from the environment maybe, and then the behavioral acquisitions are like the behaviors that result from the eyes being there, or some behavior that's generated, like motor movement. So sensory motor loop, for example, would be you'd have a sensory input through the eyes, and then if the eyes are on the sides of the body, there's a certain set of information that comes through that. Or if it's in the front of the body, a certain amount of information comes through that. That's a morphogenetic acquisition of the eyes in a certain part of the body. And then you acquire information through that to the motor circuit, which then is the behavioral acquisition, which is then, results in some sort of behavior, movement, or whatever. So that's kind of where that's going. And then the critical period is like the time when there's enhanced learning. So like you acquire things from the environment at a certain time. You also acquire things from the genome or the environment combined at a certain time. So like there's a critical period for eye development, and it has to precede the critical period for sensory sensory acquisition and then movement. So you can't really act on light from a certain direction if you don't have eyes. But so you can't have you can have a critical period for like behavior, but if the eyes aren't there, then it's all desynchronized. So that's addressed in the paper. And of course the role of embodiment is important because you have these things happening in certain places in the body. and it's grounded in this idea of Gibsonian information, which is, where you're taking environmental information and using the structure there really as the grist for some of these responses. So like this is modeled in the paper as Poisson noise that's combined with like a signal from the genome. And so you have this artificial genome that's active or inactive. So during the critical period, it's active. During regular times, it's inactive. And then it interacts, or it's basically you're convoluting the environmental signal, which has structure and everything, statistical structure, and then this potential from the genome, which is active during the critical period, and then that combines to give you a signal. And so there's a lot of modeling in here with respect to that. And so then that leads to the results, which are like a series. There's one experiment that's presented. There's another sort of conceptual graph where it shows the effect of the critical period. Then there's this section where there's a discussion on where the sensors are in the body. So there's this visual tuning example. You could scroll down a bit, Jesse, to I think figure 1 or something.
Oh, here.
Not that. Well, that one shows critical periods in time. That shows a Gibsonian information, figure 2, and the genome, and then figure 3, I think, is the one. Yeah, this one.
Okay.
So this is where you have plasticity in, so you have like their left center, right center sensors, or left, or left lateral, right lateral sensors. Those sensors are getting information from different parts of the environment. So conceivably, each sensor is picking up different types of statistical structure from the environment. And it's, so matter is where they are in the body. So that's the role of embodiment. And then these things get fine-tuned through in the critical period. So this, the signal coming into the body, in like if you think about the visual system in mammals, you have a lot of visual information that comes through the newborn eyes. So when the eyes are sort of wired up and ready to go, you get all this information, and it's really hard to make anything out. And one of the aspects of the critical period in the visual system is that it fine-tunes a lot of those connections so that there's certain parts of the visual stream that get paid attention to, certain frequencies of light, certain frequencies of patterns in the environment. So these things get tuned and then they get locked in. So that's kind of what this is referring to. There's this sort of example where there's this visual tuning, but you have to have eyes to have visual tuning work. So yeah, and then there's a part about the connectome where the connectome is also important. If the connectome is in place, then learning is fully realized. If not, so that example's in there too. So there are a lot of different things going on. Just kind of walks through some of these things that we can look at in an agent, from artificial sensory organs to artificial bodies to artificial genomes to artificial connectomes, and putting that all together.
Nice. Yeah. Yeah, and this paper is pretty much like really nicely fleshed out, but still open to people. Like I'm, as you can see, I'm suggesting stuff and review things, so it's still open to that. And this is the Alife paper. I think it's this is 8-page paper. Yeah, this is a full paper for that, and we'll turn this into a shorter abstract for EI workshop as well. So that's pretty cool. I think that covers most of what we wanted to do in terms of our submissions. Was there anything new that came up in the submissions chat this week? Let me check that again.
Oh, Vrushali asked, yeah. She said, what is the deadline of a blog post? But there's no deadline. If you want to do that, you can do it. I mean, I know we said, you could do it in March. I mean, it's fine whenever you have time. I wouldn't worry about it too much.
Oh yeah. If you're interested in that, just mention us in the Slack. Please, we'll help you do that. But it's not there's no like conference deadline we're up against for that, thankfully, because we have a bunch of other things to do right now.
There's also a submission for EI workshop that we wanted to do. I think that was, I can't remember what it was. There was another one I wanted to do, but I don't remember. Oh no, it was for Alife. It was the
Ghost in the Shell, Ghost in the Machine plus development.
Ghost in the Machine, yeah.
Yeah, that's I don't have anything for that, but that's definitely on my radar too. I think I might actually draw a bit from the paper I saw and then combine some of our stuff. That's kind of my vision for that. Okay. That's something I want to do today and tomorrow. I have not haven't totally really gotten into that one yet. So, yeah. But that's something I want to do too.
All right. Yeah.
Okay. Do you want me to just turn it over to you? I know you wanted. I didn't want to do. What else do we want to do? Project stuff, project management course.
Yeah.
The papers. Anything else? Anybody else have like a presentation they wanted to like highlight today that we didn't know about? Otherwise, I'll just turn over to Bradley. I'll mute myself for a bit here. Something you want to say, Amanda? I just saw you pop up. Okay, cool. All right.
Just turning my camera.
So we have
what? One thing. I never did the world premiere. I'll do it right now. Like
world
15
premiere.
seconds.
Okay.
World premiere.
Paper. Great.
It exists.
Sure. All right.
This is like ultra prototype lab swag. So I'm trying to develop them and find the best way to do it, and I'll see if I can disseminate them in some form in the future.
Hold it up again. Yeah,
it does exist.
Right there.
I kind of did the curve, and
yeah,
nice.
Fine. If you have a particular favorite color or something you want in a shirt, like message me. But for the time being, that's it. Okay, I'm done.
Great. So yeah, welcome. I see Ira and Raj and Vrushali are here, and Morgan's here. Thank you for showing up. Morgan, yeah, we talked a little bit yesterday about some things, and maybe there's some new things we can do coming up in the new year. Yeah, we're always constantly moving forward and thinking about new things, and like I said, if you want to contribute to the blog or something, there's no real deadline. We do have deadlines for different conferences and that, but we're usually pretty flexible in terms of doing things. And we have, our Medium, we have other things that we want to, there are things, of course, you want to maybe work on and find a submission venue for it. That's fine too. So, I really encourage people, if they want to present something at the meetings, to do so. Or if you want to just work on something and try to find a home for it, don't worry about the home right away. You can just work on things and work them out in the lab. And that's one of the reasons why we're here, because, we want to craft things, develop them, and kind of work things out. We haven't, there's also, we've done some writing, actually. In the past, we have done like writing rooms and things like that, and I think that might be of use if people are interested in that. We can, set something up there. And then what I mean by that is, if you want to produce good work, you have to spend some time writing, and it's a very hard thing to do, very hard thing to master. So it's not just automatic. And if you're not a very good writer, or if you don't think you're a good writer, it's always worth practicing. And in fact, everyone has to practice that. It's essential. So that's something.
I was going to say, if you think you're a very good writer, you still need to practice.
Yeah.
That's what it is to do.
So yeah, and so I encourage people to do that as well. So I know, like when you're at the meetings, you kind of you get the impression that this is all magical and it kind of flows from nothing, but it takes a lot of thinking, planning, and working on things like that. So Jesse, you wanted to say something?
No, I just hit the wrong button, but I totally agree with what Bradley's saying. We do want to really encourage people, blog posts or just shorter writing, shorter updates, flash talks or shorter things. Like we really want to kind of get in the process of there's the sort of discussion to be had about like the demo or die or deploy or die and just like why that matters. But basically everything Bradley said, and if there's something you want to present about or talk about or have a few minutes to talk about anytime, please just let us know. We can make time for it. So we really want to give you that experience of in-house in a nice setting, talking about your ideas, especially for like early career researchers or interns or undergraduates that are stopping by. That's really important. And I know it kind of like sometimes we just plow through stuff and like boom, 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 boom. But that's why we try to say like, hey, or like every week the email prompt is let us know so we can really try to make time if you just need to talk about or practice talking about.
Yeah. So yeah, I mean that's it. And we have like different meetings during the week for other things. Like we have our Cognition Futures meeting on Wednesdays, and we have our Evilware meeting on Mondays. And so we have a lot of things going on underneath the hood. This is sort of our main meeting, and then we have people working on things in a distributed manner. So definitely, if you're new to the lab, I would definitely explore the Slack, and then ask around and say, is this something that what are the opportunities available in this area or that area? When you see something. Yeah, so I mean, I definitely want to encourage that. We're coming up on Google Summer of Code, of course, and we're working on those projects. We have the VR project, and then we have the open source sustainability project. And so the application period's opening soon on the 20th, I believe. So this is a time for people to, if they're interested in doing that, they need to write their proposals. And so that's a good opportunity for you to get experience of writing and organizing things. And if you're interested in getting your proposals reviewed before you submit them, we're open to looking them over and giving feedback. So with respect to the VR project, I mean, that's a pretty large area, and it's hard to really pin down what you might want to do. So, maybe if you want to talk to myself or Jesse about that, we can facilitate that a little bit. But you can also write up like a proposal, kind of an outline of a proposal and send it to us to get feedback, and we'll be willing to do that. Just don't think that writing is like this one step process where you just put it all down on a piece of in a bunch of bits on a word processor, and then that's it. It's very iterative. So I just wanted to mention that. And then also, we have all sorts of conferences going on. So we review this document in meetings weekly. And so, you might want to find an opportunity there. Or, if we have submissions channel in the Slack that you might join, call for involvement, I think it's called. And that's where we put a lot of that information. So, there are a lot of ways to get involved, a lot of ways to stay, to be collaborative in the lab. All right. So I'm going to talk about the project management course. So this week was week 7. And it was interesting because I was kind of like finishing up this unit 3, which was like discussions and public documents and public meetings. So, documentation is a big part of projects, open source projects. Discussion forum, like a Slack forum or a Discord forum or, a discourse forum. Those are all very important to facilitating involvement and contributions. This week we talked about, let's see. So this week we had lectures 13 and 14. Lecture 13 was on public events. So this kind of, this is our group here. This is our Saturday meeting. The point of this slide is to say that, we have people from all over the world. They're coming together in one place in this virtual space, and we're trying to facilitate their involvement.
I don't think the screen is sharing.
Yeah. Okay, let me get this. I have to share my screen. All right. So, all right. So this is our group here. Our Saturday meetings up here. People all over the world. They're collaborating in the space. They're getting together. Then this speaks to the synchronous and asynchronous aspect of this. We have synchronous coordination in virtual meetings. We have asynchronous coordination in these discussion forums. And then this is all put together. And this is what we have to do to have a good collaborative group. And so, I go through some of the models that you can use for this. One is the hackathon model. So the hackathon model is something that people do. It's usually, it has its origins in timed competitions around a specific problem. So people have often, like we mentioned recently that there's this essay contest where they have an essay, like a month-long window where you can write an essay and then, submit it and then get maybe a prize of $1,000, or you get it published somewhere nice. So this is the kind of thing. These hackathons, though, are more focused on a couple of days or maybe a week. So the history of hackathons goes back to 1999. It was used by an open organization called OpenBSD. And their goal was to solve a cryptographic problem in a single week. So this is like a very hard problem. Maybe it involves a lot of collaboration, doing this in a single week. And so you accelerate your time scale instead of working on something for a couple months, going back and forth. You take a burst of activity and you work on it in a week. And then, this led to something at the Java 1 conference where you pick sort of the best people you could find. You put them in a space for 4 days, and you got them to write the best possible Java program. And so this is another thing where they get this notoriety of being like the best and doing this thing that was seemingly impossible and doing it all in a very short period of time. There are other events like Food Camp, which was where you invited experts to a multi-day event and you rewarded the best pitch to specific challenges. So this is where you just have experts who come together. They have to think about a problem and then come up with the best solution. In Silicon Valley, they hosted the Super Happy Dev House in 2005. And this was where every 6 weeks you'd have these 12-hour-long events where you do things like develop novel products, attract curious and creative people. So there was a networking aspect to it. And so, you can see how this hackathon model kind of brings sort of, this meeting isn't really a hackathon, but you can see how hackathons as special cases of like this meeting can really be useful to an organization and to projects. Yahoo is, had started its Hack Day in 2006. And so the goal there was to have a brand hackathon. So it's like you bring people together in your organization and you generate useful applications or ideas that are, end up being useful artifacts. So this is where, you just do this within your company. It's centered around your brand, and then you build from there. And then, in the modern era, we have all sorts of different types of workshops, different events that provide interactions with a company or organization, or things that involve technical presentations. The point of hackathons is really it's really enabled by web-based development technologies, and it allows us to locate new areas for innovation and ways to develop novel solutions. So I took this from the history of hackathons, and this is an article. I mean, this history isn't very long, but I think it's worth going over. Just looking at like where it came from and where it's going. And so this is where it's kind of going. we have hackathons like MozFest, which is very collaborative and it's actually pretty diverse with respect to the history of hackathons, because a lot of people think of hackathons as like a bunch of coders sitting in a dark room, but you can have events where you have things that aren't just about computer code. You can have things that are like celebrations. You can have events like where you're editing wiki pages. You're doing all sorts of things, very in-person and collaborative, and doesn't have to be just like this focused work session. It can be almost like a festival. So MozFest is like that. They have, it's basically an event where this is their main event for Mozilla during the year, and it's very community driven. They get volunteers to sort of develop the program and what people will be doing. Their approach is called loving creative chaos. It's a term that they use that is sort of the mentality of the festival. So it's like we want to encourage people to be creative. We want them to be very kind to one another, and then we also want there to be this sort of controlled chaos. We don't want it to be actual chaos, but we want them to be like all over the place, purposefully. So this is like kind of a thing for organizations where they're putting their name on the line and they're getting people to do these projects, and getting people to do them in a way that's reputable. It may seem like a risk, but actually people do a very good job. So the way they have this set up is they have this principle of federated design. You have facilitators who are vetted by the foundation, and they say, okay, we want you to come up with these projects. We want you to think about design. We want you to think about the specific issue. So one of the events at MozFest is Connected Cities. Facilitators will help participants contribute to a theme, and this is all determined pre-event. And then they go in a week-long retreat setting where they're at this festival, but then they go into this retreat for the specific project, and they work on the different issues in the project. And so, a lot of it is design, a lot of it is storyboarding. There's a lot of, diversity in terms of disciplines, cultures, age groups. So people are contributing their points of view, and they're very, they're not all the same point of view. And that's actually very important for these kind of events. They bring people together from everywhere, and then they solve this problem in a very short period of time, or try to solve it. It's not really about coming to a conclusion. And I think that's true of our group too. Like, we don't really come to a conclusion in one meeting for anything. We kind of follow it through multiple meetings, which is perfectly fine, and it should be that way. So then there are these other kinds of events like docathons and ideathons. Docathons are these kind of week-long coding sprints, but they're focused on documentation. So you spend time devoted to examples, tutorials, and guides. You want to have an event that sort of values documentation because it's usually not valued. You want to be able to develop materials that provide an entry point to the project. So the stuff Jesse's showing with the Notion is stuff that he's developed kind of, separate from our group. I mean, we consult, but like a lot of the work of putting that together is, separate from our meetings. But we could have meetings where we develop these things collaboratively. That's the idea of a docathon. So you can actually do things where there are things that are undervalued or underdeveloped in your community, and you can have an event to sort of bring those things up to speed. So, docathons are very useful. A lot of these athons, these kind of events, are useful in that they drive the number of commits during a specific period of time. So in this docathon example, you have very few doc commits throughout the year. But during the docathon period, the number of commits increases exponentially. So you can see it's manyfold over what it usually is. So that's one of the reasons why we do these events, is to drive involvement, to get people's minds focused on a common idea, task. There are different ways you can do docathons. You can also focus on wikis, which are documentation for public events. So, wiki is the Hawaiian word for quick, and of course we know Wikipedia. It's these kind of online hypertext publications that are collaboratively edited, so they're collaborative. People contribute to them in different ways, and then there's an editor maybe shapes it. This is something that we're familiar with, but we're not really familiar with why it's useful. So, Wikipedia has a wiki. There are other, you can have your own project wiki. And the point of this set of slides is to basically say, you can have a wiki for your organization, and you can have an event like a docathon to make sure that it gets updated on a regular basis. You can also build around like Wikipedia's set of wikis and contribute to sort of upkeeping some areas there that are not well represented. So, wikis are, a nice thing to think about for documenting your project. And you can have public events around like wiki creation and wiki editing. And then, there's wikithons are pretty useful for like getting, documentation out there, for getting topical information out there, and for doing things like, bolstering underrepresented topics. Like there's a project 500 Women Scientists where they try to increase the amount of exposure that women scientists have on Wikipedia, creating stubs for people who aren't there, updating stubs of people who are there, and so forth. And so this is a maintenance activity that's not really, considered that, considered an everyday work. This is why we need to have these events. So, an ideathon is maybe similar to this, but it actually involves a lot of brainstorming. So with ideathons, we don't want to create an artifact at the end. We want to create an idea or an actionable plan. So it's a little bit harder to kind of put your head around that. But if you start with like some topic and you say, I want to come up with an actionable plan, it might be like the origins of something that you might submit to MozFest. You can have an event that just kind of allows you to do the same principle of making commits or making edits, but thinking about things and then writing them down, building a roadmap and an actionable plan. So this is kind of drawing from the wisdom of the crowd, and there are a lot of ways you can do ideathons. And so the outcome of this is that, or all of these type of events, is that they really shorten the time frame to this minimal viable product. So in a project, you're working on building a minimal viable product, and that's shortens that time frame to get there. Plus, it also involves people coming in from different parts of your community to participate in these things and make them better. And so then we went through the sprint model and agile methodology, which is related to the sprints, are like these short periods of work activity, these bursts of work. And in agile, which is a methodology for project management, we have this formal methodology around these kind of meetings. And so sprints are basically where you have a project vision, you try to work on pieces of it in meetings, you review them, you try to do a retrospective after the meeting to follow up on things, outstanding issues, and then it's iterative, so you're doing this again and again. And so you want to make sure that your sprint is valuable for people in your project, but you also want to make sure you follow up. And so this is very important for people who, for sustaining activity in these sprints. And this also holds true for the wikithons, for the hackathons, for the docathons, to follow up after you're done, to plan for the next event, and to keep things moving sustainably. There are also failure points for the sprint model. So if you don't follow up, if you put single people in charge of things, it can be a failure point. Having a sufficient vision is also a failure point. And then finally, you have to understand that some of these models that we're talking about are good for certain types of projects, but not all projects. So one size does not fit all. And so, there are other failure modes for public events more generally. There's these, basically people have to buy into them. People have to buy into the vision. People have to understand what's going on and have a common language. And so I mentioned that in these last couple slides where, the real world audience intervenes in our best intentions. You don't want to necessarily force an agile type framework onto people who are doing something that doesn't maybe require that kind of vision. And then, there's context, there's participant affordances, like making sure people know what's, the context of your project. Those are all things that are important for keeping things from being, for people to get what they need to out of these events. Let's see, we have a couple of comments in the chat here. So yeah, brain hack is collaborative. Yeah, that's a good example of a hackathon. And then Raj said that was Morgan. And then Raj says, I attended a similar Wikimedia hackathon last week. It was really good. Yeah, very good events. I think NeurotechX hosts a lot of them, and we were, just talking about that yesterday with Morgan, how they, really kind of get some really good stuff out of there. You really get some good work. In their case, you're doing a lot of research, maybe some data analysis. You're catching up on that, getting people together. So, I think the other lecture was more of interaction, going through like a local example of a hackathon where we are in this class. You can have these local events where you get people from your local community. You can solve problems. You can solve like social problems with machine learning and data science. You can do kind of things like bring back the concept of a phone booth, building crowdsourced platforms and things like that. There are all sorts of things you can do locally and have hackathons around these problems. So, you want to host a hackathon, you have to market it, you have to have sponsors, you have to have a location, physical or virtual or both, and you have to plan all that out. You have to pick a date. These are sort of things you need to think about. I talked a little bit about project versioning to sort of tie up a lot of this. Project versioning, of course, is something where we release some software or something. We want to put numbers on it to tell people what version it is. There's this idea of semantic versioning where you have a major version, a minor version, and a patch version. So the major version is where it's not necessarily backwards compatible. It's like the difference between Python 3 and Python 2. A minor version is where you have functionality in a backwards compatible manner. So you make a release that's, got new features, but you can go back to the old version. And a patch version is where you fix bugs. And it's a very, minor thing. It's just something you might need to update things. So there's this idea of semantic versioning, which basically, if you're interested, if you're in the GSOC area, this is probably something you should check out because this will be something, your projects this will be relevant to your project. So again, this is semver.org. That's the link to the Semantic Versioning Foundation. And they have, they kind of give you these visualizations to make sure that you understand the concept. And then, in person class, we're reviewing the final version of this, or kind of like this unit, what was learned. So there were all sorts of things that we went over last week and this week in this meeting. And then they have a term paper in person, and we were discussing some of these projects. So the point is to develop this term paper about some project that you, based on an idea that you care about. And then why do you care about it? Why do you want to work on it? And then what principles can you apply to that project? So we had a number of people, a discussion on that. A number of people gave ideas and took some of these principles and said, I want to apply these principles to the project. So it's basically like proposing a project that you want to develop, something you care about, something that you can apply, say like documentation or working open or some of these other things to that project, and then discussing what that would look like. So it's definitely, kind of a practice driven, or at least proposing a practice driven approach to this. So that's all I had for this week on the project management course. Did we have any other comments on that? Okay, yeah. So it's a pretty, it's like I think 2.5 hours of content smushed into a single like 20-minute thing. But yeah, interesting history of hackathons. Yeah, it's not really a I mean, I don't know where to go with history. Like in this area, it's like the history is like 20 years. But I mean, a lot can happen in 20 years. We started with just solving a problem, and then we design a methodology around it and say, this is the best way to solve this problem. It's not as simple as you think. You just can't come together and say, we're going to, like, sounds like we're hacking around, You've seen the memes about hacking where this guy's walking down the aisle of a computer store just putting his fingers on a keyboard, on different keyboards, and like it's a lot more organized than that. So Jesse, if you could bring up that meme. You're a meme master. It'd be great.
Sorry, which one? I was getting a delivery.
This guy's walking down the aisle of a computer store, like hacking on different keyboards.
Oh yeah.
You've seen that.
I like that one actually a lot. Let's see.
So yeah. And a comment.
This one.
Oh, yeah.
Here we go.
Yeah, there we go. Hack in progress.
Hacking in progress.
Yeah.
It's in the chat too.
Yeah, okay. Yeah, so that's, there we go. All computers hacked. So that's, but it's much more developed than that. And certainly, in this group, we've tried to work on this problem of coordinating people working around the world, coordinating like around different problems. We've taken sort of a traditional academic approach to like a reading group or, a lab meeting, and then we've tried to build from that. But we still have a lot of these coordinating problems where people need to find ways to work together. And we're enabled by a lot of the cloud technologies like Google Docs or GitHub or whatever. So definitely work in progress there.
I like how he hacks the scanners too. It's that's pretty deep. You can hack the scanners for touch.
Yeah.
Okay. No, that was good. Thank you for sharing all that.
Yeah. Yeah, so let's see. I wanted to talk about another interesting thing. There is this set of papers. I know we talked about the organoids paper a long time ago, maybe about 6 months ago. And then there's been a critique of that. It was where they had an brain organoid in a dish, and they made it play Pong, which sounds, science fiction and everything. But it's basically like they've been doing this work with hybrids and with brains in a dish where they've been able to take recordings from neurons in a culture, and they've been able to take that signal and use it to drive like something in a video game where you need a motor command to drive it forward. So you say turn left, there's a motor command. You can usually use a joystick to push it left, and the avatar or the object moves. In this case, you're taking a signal from a bunch of neurons and you're decoding it as like a left turn or a right turn. And then you're providing some sort of stimulation as feedback. And, they can get these things to work. I've been doing this for a long time, like 20 years or more. People giving different examples in the literature of this. So, that's where we are with that. So actually, this is the original paper we talked about like about 6 months ago. So this is, it was a preprint in bioRxiv. I don't know what the publication actually was, but Of course, it had Carl Friston on it, so it got attention. This is in vitro neurons learn and exhibit sentience, which we talked about at the time as a very provocative way to put it, when embodied in a simulated game world. So we're using the video game as a form of embodiment. We're giving it a body in the video game, its location, its what its controller, I should say. So this is so they developed Dishbrain, a system which exhibits natural intelligence by harnessing the inherent adaptive communication of neurons in a structured environment. So these are cells from human and rodent origins, integrating it with an in silico computing environment, which is basically the simulation, this video game. They use a high-density multi-electrode array. So they're able to mimic the arcade game Pong, which is very simple. It's where you have this ball that bounces between controllers, or these little paddles that move up and down. So you're bouncing it off the paddle, and you have to move the paddle to catch the ball and bounce it back. I mean, it's a pretty simple game. And, this is just a very simple example of this sort of linear controls, first order feedback. You see the ball, the paddle is 1 degree of freedom. So if you think about, let me draw it on my board here. So I know maybe a lot of you don't know what Pong looks like. So it's basically this square. All right, it's like a game board, and then you have these paddles. And the paddle has 1 degree of freedom, so it moves back and forth here. And the ball moves, bounces off of this paddle, bounces off the wall.
I did put a GIF in the chat of Pong.
Okay.
If that helps anything.
All right, yeah. So there you go. And then you have to match this impedance, basically, where you have the ball moving towards you. You have to move it back towards the ball and bounce it back off. And then you just keep doing this until the other, this person, if they get past this paddle or this player, they score a point. That's basically it. And so the idea is very first order cybernetics, first order feedback. You have this ball bounces back off these things. You have 1 degree of freedom. And that brain signal is basically telling it whether to move right or left or up or down to match where the ball is. So that's basically the idea. So that's what they're doing. Now they're applying a previously untestable theory of active inference via the free energy principle, which we've talked about, which is basically this idea of minimizing free energy in cognition, in what they call active inference, which is where you're exploring your environment and you're making inferences about it. You're minimizing your energy and in the brain while doing this, or you're minimizing error. All those things are kind of related in that theory, and they're able to test the theory and say, yes, this is consistent with the free energy principle. And I guess it has something to do with sentience, but that's how they kind of frame this in this paper. Now, there's a response to this, which is where I think they beat the hell out of the sentience idea, first of all, but that's an easy target. They actually want to talk about emergent intelligence in those claims and how maybe they're not, and maybe they're misguided. So this is a response to claims of emergent intelligence and sentience in a dish. This is in the journal Neuron, a bunch of authors. I'm not familiar with any of the names, but anyways, so go ahead, Morgan.
I can recognize some, but I think you can also see that it's got a certain geographic.
Oh, in France, yeah, I see.
Yeah.
Netherlands, yeah.
But I recognize Svoboda there.
Okay, yeah, great. Yeah, so this is this article here. A triggered wave of positive mainstream and scientific media coverage, as well as the widespread negative reaction from the scientific community. So it's like the media thought it was great. The scientists always think it's like horrible when something like that happens, usually because the scientific media tends to get excited about things that don't have a lot of deep content. I mean, if it's like you can if it's flashy, they love it. It's like, but it's hard to like see the scientific value in some things that get a lot of buzz in the media world. But anyways, we raised concerns about the key claim of the article, that it demonstrates that a single layer of in vitro cortical neurons can self-organize activity to display intelligent and sentient behavior when embodied in a simulated game world. Our concerns go beyond the appropriateness of the methodology, quantification, and controls, and the lack of details for which are presented. These concerns include the unsupported use of terms and concepts that misrepresent the findings of the study, which I think they're referring to sentience, the lack of an acknowledgement of previous literature. So it was interesting. I saw a post from some of the people I follow on Twitter, and it was there were some groups in Japan, for example, that did some work on this, and they didn't cite them. I mean, like I said, this kind of work, brain in a dish, has been around for a while. People have done different studies on it, so it's it's always hard to find all those studies. There's a whole field of what they call hybrids, which are like hybrid robots and cultured neurons that is relevant here. And then in the ensuing overselling of translational and societal relevance. So this is always a thing that people do, because it's fun. It's friendly to funders. They want to know how this is useful to the real world. But sometimes people just kind of oversell it. They say, this is relevant to cancer. Well, maybe not. It's... Morgan, did you want to say something? Or?
Well, I was just going to say that they kind of Dishbrain, excuse me, Dishbrain has been around for a long time. I mean, I certainly think of like, UC San Diego, I think did some of the first work of just, studying stem cells from patients, versus controls kind of thing. Yeah. Just looking at connectivity, looking at electrophysiological activity. But Dishbrain really did seem somewhat new in terms of adding feedback and really focusing on the interface between an electronic system and a biological system. Yeah. More so than others.
Right.
Like,
Yeah. It's definitely it's not just as simple as getting the feedback. I mean,
right. But I would definitely, having gone through the Dishbrain paper, there's not enough details to recreate it.
Yeah. It's always like how much. Well, I mean, method sections are always tricky because you have to spell out kind of how you might reproduce it. But sometimes it's hard because you have proprietary stuff you don't want to mention. It's kind of like if you're in a lab where you're doing this and there are 5 people in the world to do it, they all do it a little bit differently. It's kind of hard to like say, well, anyone's going to be able to do this. There's certain things that are kind of hard to get, make reproducible, I guess.
Yeah. And in this case, there is a company. There is, they are trying to develop IP and build a company. Yeah.
So let's see. So their critiques, I think, are really kind of centered around those things. They make one point here. By associating elements of cognition with the properties of cultured neurons, the authors inevitably created a media buzz. This paper also attracted a lot of attention in the scientific community, in part because of the concerns about concept hijacking, which is, or at least misleading usage. So that's an interesting thing. They coined this term. And it just means like you might say something is sentient when it's not really sentient. It said you're using that term to sort of describe something that you want to, like, it's like sometimes people misuse the term consciousness to mean things that aren't really consciousness. But, that's, oh, yeah.
Well, I know people who are upset with Meta's name change because they consider that concept hacking.
Yeah.
Yeah, that's a very good example of like, it's like if I made a group called like, I'm the embodied cognition company, and we make embodied cognition. Cool.
Yeah. Yeah. So I mean, this goes through some of these things. For example, attributing intelligence to a network that displays short-term plasticity is not supported by the relevant scientific fields such as machine learning, neurobiology, and psychology. So, it's just that when you have the short-term neuronal plasticity, it's not necessarily intelligence. There's a whole set of terms that people use. So, short-term plasticity is when you have, like we talked about synapses in previous meetings, those synaptic connections are sort of adapted to interacting with one another. There's this association of two neurons through the synapse, but that's not intelligence. That's just learning or short-term learning or encoding things. There are different terms that people use for those things, and not necessarily, that's not really the basis of intelligence per se. Oh, Morgan, you were going to say something.
Well, it's just kind of funny. I mean, that paragraph. I haven't seen this paper. This is interesting. But have they seen the reaction of people to Chat GPT?
Oh yeah.
Do they understand that this might be more than just like a Dishbrain thing?
Yeah, it's really becoming very common. Like, intelligence being what is intelligence, and then of course using that term loosely can be very dangerous in ways.
Yeah, the Francois, is it Chalet, the Keras developer, I think has some of the best stuff in terms of, it's someone focused on trying to design tests of intelligence, right? And but not focused on any particular technology or any particular, trying to as he said recently, like something like, I didn't design art to be hard for LLMs,
right?
But the fact that it is probably a good thing, or is to the point. Yeah.
Right. So yeah, it's definitely, there's a lot there that so similar arguments apply to the more provocative use of the term sentience. This application of neurons in vitro is, in our view, even more inappropriate and not justified by the data. The term sentience is notoriously hard to define, but refers to a process that encompasses feeling, sensing, and subjective evaluation. So this is something that you'll see in like cognitive science. This whole idea that you can reduce psychological phenomena to what's going on in neurons. And this is this is relevant, I think, to our cognition future stuff, that there's this, there's this pushback, I think, by more neuroreductionism, pushback by more cognitive oriented people to say, well, we can't really say that we can observe these neurons and they're doing this thing and that's what is intelligence. There's, maybe more to it. There are networks involved that are, doing things. And there of course are arguments that maybe you're trying to invent an agency that isn't there, but that's a debate, that's something that we haven't really worked out, that people will go to the mat over. So that's the critique of this original paper. Also, they don't acknowledge previous use of biological neural networks embedded in closed loop systems. So what we're doing here is we basically have these neural networks embedded in closed loop systems. That's the embodiment aspect of it. That has helped, for example, to assess the potential application of plasticity, which is not learning, it's plasticity. So plasticity is adaptation, but it's not, it's maybe learning, but it's not intelligence. And so all those terms are really kind of, I found that like when you write about this stuff, it's like you can go from defining plasticity to defining intelligence to defining learning to defining maybe something that's proto-learning, maybe proto-intelligence. There are all these different gradations that you need to be aware of when you're writing stuff and describing it. And even when you're modeling it, even more so, I think. But so these kind of systems have helped to assess the potential application to drive external artifacts like robots. So there was, this hybrid area they're really driving robots, and the robots are much more embodied than, say, like a video game, where you have this signal. You basically have this graphical representation of an environment, and you have to move in one dimension. With a robot, of course, you're moving maybe in two or more dimensions, and so it's much different. It's and then there's this whole issue of what do we mean by embodiment, and what's the value of having something in the environment, and what's the value of its body with respect to that. So if the body's moving and you're encountering things from the front versus the sides, or if you're interacting with your environment but you're moving things towards you versus away from you, what's the value of that with respect to some of these cellular level things like plasticity? There's been some really fascinating work on it, some of which we've talked about in the Cognition Futures group. There's been stuff on tool use. There's been stuff on with these hybrid environments where you're able to see things that get manipulated over time, and there are things in neurorehabilitation where they've been able to take sort of the human, or I guess they could take they take something out of the loop. I can't remember how they do these experiments, but basically they can get the brain to recognize things without having you have a robotic arm, and you have the brain kind of sending a signal that is sort of replaces a limb. So you have this, you can manipulate things in the way that you might manipulate things with a limb, but you're not doing it with a limb, you're doing it with the brain. You can train the system to do that. So go ahead. Let me say something. Okay. So there are a lot of ways that this is done in the literature. And so in the present specific case, claiming that a cell culture embedded in a closed loop system demonstrates sentience and intelligence might impact the public perception of what in nature is sentient and intelligent, and could trigger ethical debates fueled by misunderstanding. So, a lot of these terms, it's important that we get them right. And it's important we know exactly what these experiments are doing. I think that's the lesson. That's not much a critique necessarily of that work, but it's a critique of the way we think about these things. So the final paper in this group is this organoid in a dish paper. And so this is, I know Morgan posted this in the Brain Organoids channel, and I saw this paper as well, and I think it's really interesting. Or Morgan?
I was just going to say that some of these people are also working on organoids technology and like biotech work that is really interesting too. Was one of the things that grabbed me was I think Brian Caffo is on this paper,
yeah.
And some of the new institute work there at Johns Hopkins. So yeah, it's interesting, even though this is very much a a blue sky conceptual paper.
Yeah.
Dishbrain at least is an actual experiment.
Yeah, this is more of a blue sky. So Josh Vogelstein and Alison Motry are on it. So there are people from AI, or people from organoid research, or people, so this is
I totally missed that Allison's on there too.
Yeah.
Okay. Yeah. So that's somebody who knows something about
organoids. So this is just kind of going over maybe this idea of organoid intelligence. So if some of the people in the group aren't maybe familiar with what organoids are. So organoids are these structures, three-dimensional culture structures. So there's cells that are grown up into a culture, but they do this in a three-dimensional, maybe like a bioreactor, where they take cells and they seed like this culture, maybe like stem cells or neural precursor cells, and they get them to differentiate into different types of cells, different types of neural cells in this case, and they can generate what is basically an organ. So it's it has some shape, it has some function maybe, electrical function, not necessarily like, exactly like the organ that it's trying to replicate. But you can have things like, like little livers, little, guts, little brains, and they have layers of cells. So they're actually, going in the direction of becoming like that organ, but they're organoids. So you can do experiments on them and you can test hypotheses, or you can look at like maybe how to get to building an organ from taking stem cells and differentiating them into different types of cells. So they're kind of thinking about this in terms of organoid intelligence and how we might build some of these brain in a dish applications as these three-dimensional structures as organoids. And so there's a lot of stuff, the bioengineering involved, a lot of other things that we need to think about that are not so important to this, although they're very critical to making good brain organoids. But what basically happens is you can get standardized three-dimensional myelinated brain organoids, which means that the axons have myelin, which means that they're more like what you see in the brain, in a mature brain or a semi-mature brain. And myelin is this sheath that builds around the axon that helps with conduction of electrical pulses. So, if you want to have organoids that have electrical signals that are like maybe adult brains or, later developmental brains, then this is the kind of thing you need. So there are a lot of technical things. Okay, thank you, Jesse. Technical things you need to overcome for this. And this is, so they're kind of getting at some of this as to how do we get to something that might look like a brain in a dish, but as an organoid. And so then they were going to raise the ethical aspects of this, and then some biocomputing applications. So, it allows for faster decision making, continuous learning during tasks, and have a greater energy efficiency and a data efficiency. So this is what they call intelligence in a dish. So they've moved up from brain in a dish. And then you can actually look at things like pathophysiology or degenerative diseases, which is something that they do with organoids now. But you can also look at like how they're functioning, sort of you can imbue some intelligence in them. And it's much better, I think, for a lot, because, the brain is not just a structural organ like a stomach or a liver. It's the basic thing of the brain is it's processing information in some way. And we've talked about this with respect to Fuchs in our cognition futures group, where, what is the brain? Is it an organ that resonates information from the environment, or does it generate information de novo? Well, we could actually answer some of that with something like an organoid, using an organoid approach. So they have these key points in the paper, and then they kind of go through their vision for the Organoid Intelligence program. They compare the supercomputer with the brain, which is something everyone does, as hardware, but, these are all estimates. And I think this is really good. This is a figure here. This shows a little organoid in a mount where you have this microelectrode array that's three-dimensional instead of two-dimensional. And it's taking the signal from the organoid, which is a lot of neurons, and it's delivering a stimulation through a probe, but it's also recording.
And that was one of Johns Hopkins' innovations, is the 3D MEA.
Okay, yeah.
Or and they put it as making little EEG caps for organoids.
Yeah.
that was their popular press marketing for that particular paper.
Wow. Yeah. So, they're like the inputs here are electrical signals, chemical perfusion. So these organoids have to be grown in a chemical environment that's similar to the brain, similar to the body. And then they use something called optogenetics to like probe the function of the neurons to make sure that they're like neurons, and which is not a trivial thing, because if we're arguing that these are like neurons that we're going to record from and have intelligence, they have to have ion channels and they have to have like coordinated action potentials. And so you can test those with optogenetics, because when you go from stem cells or precursor cells, they don't have the ability or the competence to generate action potentials. They don't typically have all the ion channels needed to do that. So, we can monitor the development of these things throughout the genetics and then get to a point where we can actually record coherent signals from these structures and then map them to some sort of environment, like a robot or a video game, where we can actually use them as signals. And then we also need to have some machine learning algorithm to interpret the electrical signals into something of a decision point. Like, we can have these signals that are very noisy, and we can say if they go above a certain threshold, turn left; if they go below a certain threshold, turn right, or stay in place if there's no signal, no coherent signal. So there are a lot of ways you can like take those recordings and play with them and get to the point where you can say, this is a command. So this is relevant to brain on a chip as well as the organoid on a chip. And then these are the cultures. So in 2D, neural cultures are very much like they can make contacts across the two-dimensional grid, which means that they have limited contacts. In a three-dimensional neural culture, they're coming from all different directions, and you can have a greater cell density, a lot more synaptic connections between neurons, and then that enhances synaptogenesis, so it enhances opportunities for connectivity and for plasticity. So this is the maturity of these organoids, these balls of cells, and they get more dense and more mature over time. So it takes several months, I guess, to grow these. I know that Morgan knows a little bit more about that, but
I mean, you can keep growing them too. It's a question of how old, how much new differentiation and new tissues and how close you can really create the organoid to a native one,
right.
Because like here, there's no. It's important to say that there's no blood vessels being grown here.
Yeah.
There's no the other kinds of getting all those different tissues and cell types to express and differentiate is really difficult, and like you said, has to all be done artificially in terms of timing, growth factors, timing, everything that you'd want to develop, right? So I saw some of they're trying to develop some of the immune system along with the nervous system, right? That's trying to do both together, super hard, and is like, these are all active research areas. Yeah. So it's getting it to be not just a ball of neurons is the hard part.
Yeah. Yeah, there are a lot of problems though too with like keeping them healthy, because you have to put them in a cultured medium. So you have to add like different types of growth factors. You have to, because it has no immune system, it has no blood supply. So it's all dependent on the environment you create for it.
Yeah. And how to and and the same kinds of problems that you have with animal research in general, in terms of you want to kind of see these snapshots of all these different weeks, right? But how to image that 3D and not destroy the tissue, right? Like so there's like other really interesting things going on, how they're doing that. But really it's still interesting to see all these people presenting this work. And I just dropped a link or say something that there's another big area of research in neuromorphic computing.
Yeah.
And which is kind of how they set up the paper in terms of the impetus for it. Right. Like how to make a supercomputer that uses kind of brain level energy. It has energy efficiency like the brain. Right?
Yeah.
And a lot of the spiking neural network work can be related to neuromorphic computing, and being able to reduce the energy costs of modern electronics, right?
Yeah. So that dendrocentric learning paper we did like 2 weeks ago, that was the focus of it, where we had,
Okay.
you talked about energy consumption. We talked about dendritic computing, which is where
Yeah.
you're using dendrites to compute things and then bringing that into a neuron or an artificial
Sure.
neuron.
Sure.
Yeah. So Ira says event cameras are also emerging as a nice neuromorphic device or a set of devices.
Okay.
Yeah. So I'm not familiar with event cameras, but
Okay.
yeah. And then so there's that. There's dendritic computing. Then there's last week we talked about synaptic computing, which is focuses on the synapses, and like we talk about synapses in neural networks, but they're very just weights. They're not considered as like biological synapses, which are like neurotransmitter specific. So it's very different. If you want to mimic that, so there are a lot of different methods that are emerging for this. And yeah, I think this is really interesting. It's definitely stepping back from neural networks and saying, we're talking about like intelligence and sentience and neural networks and large language models, which is probably not good. But but why are we saying that when we have all these other types of computing? I don't know.
Yeah.
So so I think we'll have about 10 minutes, and I'm going to finish up with another thing here. I'll talk about maybe I'll talk about enriched learning. Yeah. So this is a paper, enriched learning. This is from Trends in Cognitive Science. This is enriched learning, behavior, brain, and computation. So this kind of stitches together what we've just been talking about. And we've talked about this in our meetings before. We've talked about multimodal enrichment, which is where you have different types of sensory inputs coming in and getting merged together. And, I think people have been talking about this for a long time. People have studied this in the brain where they look at like auditory stimuli and visual stimuli and how when we bring those together in a percept and they're consistent, we get a huge increase in the representational capacity of that thing. So like if you have a sound and a vision or an image and a sound that's associated with it and it's congruent, meaning it's coming from the same place, it's much the neurons that represent that multimodal integration are much more active. And so that can mean that you can have enhanced learning, enhanced interaction, enhanced cognition, basically. This has been something people have been working on for a long time. There's like multimodal, like multi-sensory learning, things like that in education, but there's also in neuroscience. So there are a lot of different fields that are sort of drawn to this idea. So the abstract here reads the presence of complementary information across multiple sensory or motor modalities during learning, referred to as multimodal enrichment, can markedly benefit learning outcomes. And so they ask the question, why is this? And so here in this article, they integrate cognitive, neuroscientific, and computational approaches for understanding the effectiveness of enrichment and discuss recent neuroscience findings indicating that cross-modal responses in sensory and motor brain regions, so these are different parts of the cortex, sensory cortex, and then motor cortex. So you have, say, the visual area communicating with the motor area, sending signals through a series of pathways, processing the visual information, integrating something like auditory information, and then moving to the motor region, which then sends a command to move. So you might move your arm, you might move your body, and that's based on this prior information about the environment. So these things casually contribute to the behavioral benefits of enrichment. So behavioral benefits are, have a multiple range of benefits. The findings provide novel evidence for multimodal theories of enriched learning, challenge assumptions of long-standing cognitive theories, and provide counter evidence for unimodal neurobiologically inspired theories. So unimodal just means like if I have a theory of vision, or if I have a theory of audition, which means I have a theory that vision is everything in cognition, those sorts of things are being challenged here. Enriched educational methods are likely effective. So it means that when people want to, in education, sometimes they'll have multiple modalities and engage students that way. These are likely effective not only because they engage greater levels of attention or deeper levels of processing, but also because multimodal interactions in the brain can enhance learning and memory. So here they say that multimodal enrichment can enhance learning in a variety of domains, such as letter and vocabulary acquisition, reading, mathematics, music, and spatial navigation. Cognitive, neural, and computational theories of enrichment attribute the benefits of enriched learning to either multimodal or unimodal mechanisms that interact. Neuroscience research shows that sensory motor areas respond cross-modally to enriched items following learning, which means that there's a response in the visual path. If something comes in the visual pathway and the auditory pathway and they get integrated, you can associate certain images with sounds or certain sounds with images, and that effect isn't just restricted to that cross-modal interaction one time. It affects all of learning. So these brain responses occur during early stages of perceptual processing. So if you're engaged in multi-sensory learning, which you are in development, it enhances cognition. So you don't, I guess you could have only, if you're deaf, say for example, you don't have the benefit of audition that can affect your learning in ways that, people who aren't deaf can learn that there's enhanced learning there. Or sometimes deaf people will take other sensory modalities and use them to substitute for these things that you would get with audition. So it's very interesting how these things interact and how they can be sort of replaced in learning. But those sort of enhancements, those sort of associations are important. Recent neurostimulation studies, which means when they stimulate the brain, reveal that cross-modal brain responses contribute causally to the behavioral benefits of enrichment. These findings support multimodal theories of enrichment and update and constrain cognitive and computational theories. And then finally, they do a lot of translational work with respect to classroom experiments, which then have yielded promising results. So it's really interesting. They talk about movement-based learning techniques in education. They talk about multimodal enrichment. They talk about cross-modal brain responses. And they have a glossary here. These are things that they bring up in the article. If you're interested in learning about this area, they have a nice glossary here of terms that would help you understand it better. We have, Raj had to go, thank you. And Morgan had to go. So, yeah, I think that's great. Do we have any questions about that paper, or? I know that was a very quick overview.
Yeah, no questions, but that was really neat.
All right. Well, thanks. Thanks for being at the meeting here. I'll post the papers I talked about today in the Slack, so we could talk more. Maybe next week we'll talk more about some of these things if we want to. We also want to make sure that we stay on top of our submissions and make sure that we get them in by our date. I think for the EI conference, we decided March 10th is a good deadline. For Alife, it's the 13th. And I'm also working on this community sustainability paper with our GSOC students from last year and Jesse and myself. And we're just basically writing up what we did. So I'm working on that, getting that all ready for the format that they need. And I think I may want to talk to Brian a little bit, but other than that, I think we're on track for that. Yeah. So, all right, anything else before we go? Okay. Well, thank you for attending and see you next week.
Yeah, see you soon.
See you soon. Bye.